Hi everyone, my name is Yiğit and I am a student in the Bilkent University. My major is electrical and electrical engineering. Today I am going to present you my Physics-102 laboratory project. In my project, I look into the relationship between the electromotive force with the radius of the coil and the number of loops. Before diving into details, let's look at the design. Design is very simple, but it is effective for demonstrating the law of the Faraday. I used 3 copper coils which has got same radius but different number of turns, which is 200, 400 and 800. I also used 3 different coils with the same turns, which is 10 but they all have different radius, 2 cm, 4 cm and 6 cm. I used a magnet for creating magnetic field, a multimeter for measuring the voltage, and lighter and sandpaper for making the conductive wire, because my wires aren't conductive and with using them I make them conductive. My experiment has 2 parts. In the first part, we will see the relationship between the number of loops and the EMF, and in the second part, we will see the relationship between the radius and the EMF. And these are my coils. In the first part of my experiment, I focused on the number of loops. I used 3 coils with the same radius, which is 1, and the turns are different, 200, 400 and 800. I connected them in series circuit using crocodile cables and then add a multimeter to measure the induced EMF. The K was keeping the magnet's velocity consistent, so it was always rated the same fixed height to ensure the uniform change in the magnetic flux. Now this is the second part of the experiment. In the second part, I investigated the effect of coil radius this time. The number of turns was kept constant, which is 10, but the coils had different radius, 2 cm, 4 cm and 6 cm. Just like in part 1, I used a fixed height for relating the magnet to maintain consistency in the results. Now let's look at the results. In the first part of the experiment, we keep the radius same, but we change the number of loops. When we increase the number of loops, the EMF is also increased. For example, in 200 it is 0.048 and in 400 it is 0.084. We increased the number of loops and it's also increased. And these are the results of the second part. In the second part, with a constant number of turns but varying radius, a similar transfer observed. For instance, for a radius of 2 cm, the EMF was 0.0063 volts. This showed that a larger enhances the magnetic flux while leading a higher induced EMF. And this is the plot of the part 1 with the worst line and the best line. And this is the plot of part 2 with the best line and the worst line. Now let's look at the error percentages. In the first part, the biggest error percentage is 8.7, and it's not a big deal relatively. The error probably because of the unstable velocity, and it is harder than you think to maintain the same velocity. And these are the error percentages of the second part. In the second part, there is a relatively big error, which is 12%, but it can be caused by the same reason as part 1, which is unstable velocity, or it can be caused by the improper sanding by me. The sanding is important because if you not sand, the cable aren't conductive and you cannot measure the EMF. And this is the end of my video. Thank you for watching me and listening to me.